Integration. The purpose of integration at this level is to reverse the process of differentiation. So if dy by dx is the result of differentiating y, then y is the result of integrating dy by dx. This video will look at the process of integration and then give an example on finding the equation of a curve given dy by dx and a point on the curve. It is assumed that you are able to write terms in index notation. If you need extra practice, follow the link to the indices video below. When we integrate the function x squared, the process is written as shown. The elongated s and dx represent the statement integrate, elongated s, the expression x squared with respect to x, dx. Let's look at the process. To integrate a term in a polynomial, you add 1 to the index and then divide the term by the new index. Remember the acronym DMSIAD, don't meet someone in a disco. DMS stands for differentiate, multiply and subtract 1, and IAD stands for integrate, add 1 and divide. Before integrating a term, you must ensure that it is written in index notation. Here are some basic examples of the process. Applying the rule add 1 to the index and then divide the term by the new index, the integral of 8x cubed is 2x to the power of 4. The integral of 4 is 4x. Think of the 4 as 4x to the 0, so that we add 1 to the index and then divide by 1, which gives us 4x to the 1, or 4x. In general, the integral of a is ax. Recall that the differential of a constant is 0. As a result, when we integrate, we have to consider that there might have been a constant which vanished during the differentiation process. So we write plus c after our integral, just in case. This is particularly important when finding the equation of a curve from its gradient function. On the following slide, we look at terms which need to be rewritten in the form ax to the n before we can integrate them. The square root of x is x to the half, and the cube root of x is x to the third. 8 over x squared is the same as 8x to the minus 2, and 6 over root x is the same as 6x to the minus a half. Once each term is written in index notation, we can apply the rule. Don't forget the plus c. To finish, here is an example on finding the equation of a curve given dy by dx and a point on the curve. A curve has dy by dx equals 3x to the power of a half minus 4x plus 3 and passes through the point 4, 3. Find the equation of the curve. So integrating, we get y equals 2x to the 3 over 2 minus 2x squared plus 3x plus c, but we don't know yet the value of c. Substituting x equals 4 and y equals 3, we find that c equals 7. So y equals 2x to the 3 over 2 minus 2x squared plus 3x plus 7. Again, you need to know your indices because you need to work out that 4 to the power of 3 over 2 is 8.